Hi everybody, I'm Nir Strulovitz from Project Ramanujan, and today we will start in our first course. It's based on the book Experiments in Topology. I'll write it down so you can read it. Experiments in Topology. It's by Stephen Barr. And it was published by Dover Publishing. I bought it in a Kindle, Amazon Kindle format. You can buy it in a paperback or loan it from a library and so on. What we will start with is the chapter 1. Chapter 1 is called What is Topology? Okay, so our question for today is what is topology? We will start with the basic things and move on from there. The board is not perfect, but we will have to make do with what we have. Okay, so first of all, the author says that the name of the book, Experiments in Topology, it doesn't mean that we are in the making experiments like in new things in topology. We don't discover the most cutting edge things. Of course, we just began. We are seeing making small experiments, like not forward, not advancing the whole field of topology, but sideways, like making small excursions, small trips around things that are known, but discovering them in a different light, in a different way. Okay, so back to our question, what is topology? If we try to define topology, it's a little hard, because it's very amorphic in its nature. it's far from what we are used to feel and to see in the real world. It's very important and it's very useful, but it's not very connected to what we see in everyday life. For example, if we try to define, I'm taking different fields and making a parallel, trying to explain why it's hard to show what topology is through examining different fields of mathematics. Okay, so if we have arithmetics, which is the most simple mathematics, okay, it's like the counting, if we count something first, second, if we multiply, divide, all the simple mathematical things that we do with money, for example. So we take arithmetics, which is the mathematics of the everyday mathematics that we know. Okay, so we go to the supermarket and we buy 2 apples and 3 oranges, and we how many fruits we bought, this sort of things. And if we, so let's say it's the mathematics of simple numbers. Okay, let's call it that. So it's like 1 and 1 plus 2 equals, and so on. So if we make a generalization, make it more generalized, we don't just want 1 and 2, maybe we want 2 and 3, or some other numbers. We want to make it more general with x and y. So this arrow will represent making it more generalized. We have algebra. And algebra is more generalized, less concrete. It's not these numbers only. It can contain, it's more powerful, but it's less connected to what we do in everyday life. It's things like x plus y, and so on. Okay? So if we, in the same way, we want to see where topology came from, it's like the generalization of geometry. If we take geometry, okay, that came all the way back from the Greeks, from Euclid, and he talked about like specific shapes, okay, very concrete. We have a triangle, and we have a square, and we have a circle, and we make it more generalized, okay, like we did here with the arithmetic. So then we get topology. So topology, I don't have a way to draw it because it's more generalized, but it's like I'm giving you an amorphic shape to symbolize that it's less concrete and more generalized. Okay, so things like that. It deals with spaces which are